Okay, remember that a function is exactly equal to its Taylor polynomial plus the remainder. As n goes to infinity, the Taylor polynomial becomes the Taylor series, or the Maclaurin series. And that is exactly equal to the function if, as n approaches infinity, the remainder, or the error, approaches 0. So if the remainder goes to 0 as n approaches infinity, then the series converges to the function. All right, the instructions on this problem said, prove that the series converges to the function. So we just need to show that the remainder converges to 0 as n approaches infinity. So to do that, we're going to use the Taylor remainder theorem. Recall that this seems complicated, but it just comes from the Taylor polynomial formula, whereas the nth degree Taylor polynomial stops after the nth degree term. The first unused term would be the n plus 1th degree. So the n plus 1th derivative, x minus c to the n plus 1th power over n plus 1 factorial. Well, this problem number 13 is Maclaurin, so it's centered at 0, so c is 0. And the difference between the Taylor error bound and the Taylor polynomial formula is the c and the z. This z just needs to be somewhere between the x value that we're putting into the function as input and the c value where the function is centered. So we're looking for the maximum n plus 1th derivative for some value between x and, in this case, 0. Well, our function in this problem 13 is cosine of x. And however many derivatives we take, the derivative will always be either sine or cosine or negative sine or negative cosine because f is cosine. So the maximum value of any one of those potential derivatives of this function will be 1. So we'll use a 1 there. X minus 0 is just x. And now we're ready to take the limit as n approaches infinity. And we know that the factorial function grows a lot faster eventually than a power function. And therefore, this is equal to 0, and we've done it. We've proven that as n approaches infinity, the remainder is equal to 0. And if the remainder is going to 0, then the Taylor series is converging to exactly the function.